startup company in Germany with a very interesting backing, thinking about long-term energy storage and a thing which is called power to gas. And I would like to tell you the story, but this gentleman can do it better. He's called Stephan Rieke of Solarfuel.
Thank you very much. Yes, what I want to phase out a little bit is the problem we need in the next future for integration of renewable energy fluxes. Perhaps if you calculate only the amount of 55, 60 gigawatt of renewable capacity now installed in Germany, then you can face the problem we will see with these exceeds or surplus of energy which is incoming now in our energy system. And when you calculate these systems, there's a simulation of our colleagues from the Fraunhofer Institute of Wind Energy, then you can see you have to match a huge amount of energy exceed into this time ranges where we must need this from the point of the load, and therefore the task or the challenge will be high energy is incoming and you have to store it not only for hours, also for a huge amount of days, perhaps weeks or months, if we will feed a system with a 100% level of energy in the next future. And why is this important also to phase out a little bit about the possibilities of energy storages? Of course, we have the battery or flywheel systems which will feed us for some minutes to some hours, perhaps, the energy, and we will need these energy systems, but in fact, you will see it on the right side, the chemical storage capacity of hydrogen or renewable methane, which is stored in an existing infrastructure, like the gas system, for example, then you can store a huge amount of energy and for a long time range. For example, not only for hours, you can store it for days or weeks, and charge in and charge out will cycle for these time ranges. And that is the basic principal idea, that our consumption of energy is not only focused on electricity, like you've seen it on the left bar, with 620 terawatt hours of electricity. We also, in Germany, we have a huge amount of consumption of energy for heating. It is more like 950 or 930 terawatt hours. And also we have, of course, the need for mobility. Everybody of us is driving, of course, as well. And therefore, I want to focus a little bit on this system approach to combine different sectors fed by renewable energies. And if you will see on the second bar here, the energy storage capacity of our existing electricity system, the bar on the left side, it is not a mistake. We have only energy from 40 gigawatt hours that will provide our system for approximately only half an hour or a little bit more, but not more at the moment, based on pump storage capacity in Germany, for example. And this will not exceed so different in a different greater way if you will combine it with Austrian or Swiss or Norway, because these systems also will be used by other countries and also faced by problems of connecting these units. And if we can see the possibilities and capabilities of the natural gas system, this is the capacity of the natural gas system, which is existing underway, then you can see that is a quite good idea, perhaps, to combine the gas system with this huge capacity of energy storage and its distribution system with the problem and the challenge of integrating and storing a huge amount of electricity, perhaps. And the system in Germany, you will see on the right side on the map also, we have 47 installed and under operation caverns and gas storage units, which are under operation for the normal way of heating, but also for gas power devices, combined with a huge energy distribution network, the gas system, a piping system, which you will not see, that is under the earth. And so it is quite huge amount of asset, which is underway in Europe, for example, 500 billions of euros are invested in this system. And now the combination of this gas system with the electricity system is our basic principal idea. On the left side, you see the classical electricity systems faced by wind and solar energy, and we are matching our devices as a company which is engineering and procuring these energy devices like electrolyzer unit and a methanation unit. And these two different units, we are combining. The system approach is our business. And the electrolyzing unit, for example, to produce hydrogen, is a quite old technology, available since the mid of 1900. And we only adapt these available technologies for the future demand. For example, to operate it under dynamical behavior, facing the volatiles, fluxes of energy. And the methanation, for example, is also an old technology. It was invented by a French mister in the 19th century, and he got a Nobel Prize for this technology in 1912, but nobody was interested to use CO2 as a reduction molecule to face it with hydrogen, for example, because nobody needed this. CO2 was an exhaust gas, but no reaction product for a carbon dioxide cycling economy. And our basic idea is to integrate these devices based on electrolyzers and combining it with methanation. And the CO2 we will derive in the first approach from, for example, an existing system device as well. Biogas plants, for example, in Germany, we have over 7,000 biogas plants under operation. 10,000 sewage treatment plants, we have breweries and also ethanol production units as well, for example, steel and cement industry. These industries and, for example, these biogas plants are the most available CO2 sources at once. We have not to invent or to build it up. This was not our business model. We want to face different existing systems and to connect these systems together, to put a part and an advantage for an integration technology. And if we had introduced the gas into the natural gas system, then of course we can reuse it for cogeneration, for example, for gas turbine to produce electricity, but also the natural gas is available for heat or for mobility, for example, and that is also existing technologies. And our basic principle is only to integrate it in the electrolyzer unit, which we will also buy from some manufacturing companies, and adapting these technologies in our way, in our efforts we need, and the matching of these electrolyzer units and the system integration with the methanation, which is also a technology which is quite available from the chemical fixed bed reactor, for example, which we also are adapting to our needs and system integration. And the electrolyzer, for example, I've brought up an example of the last 80s. In Germany, we had some experiences and technology available for electrolyzer units, for example, the alkaline electrolyzer units, which we are focusing on. And these experiences from our colleagues from the Center of Solar Energy and Hydrogen Technology, we are combining it to a new approach of system integration. Here you see some examples of former time existing electrolyzer units, which had a better efficiency level and were also constructed for the operation under dynamic conditions. And we are reacting these technologies. We don't want to invent a new way, that is not our business, reacting and refurbishment, perhaps you can say, for this technology. And the basic principle is the electrolyzer unit, which is operated under the dynamic way of energy fluxes like wind and solar energy, which was done in the 80s, for example. It is no doubt about this. This electrolyzer unit, we are connecting to the methanation unit, which is just only a tube, for example, where the feed gases are provided, CO2 and hydrogen, for example, from the electrolyzing unit, and then by passing this tube system and the catalysis reaction, you will get a natural gas similar product, a synthetic natural gas, SNG we will say to this product. And this is a quite one-through flowing process. We have no additional cycles or stages in the moment, and we only want to integrate it in a quite similar way, like it is done in the chemical industry as well, the so-called fixed bed reactor, for example. It's an industrial application. And what we can get out from the yield of natural or synthetic gas is over 60% from the incoming 100% of electricity. 60% is the synthetic gas, which you can use in the natural gas system, and up to 30%. Of course, normally it could be a loss, but we want to integrate like a cogeneration project where you also use the heat from the lost side, and therefore we want to integrate it normally with biogas plants, which will need heat as well, or cogeneration projects, for example, to feed some local heat grid networks, for example, to use this heat. And if you will calculate the overall efficiency not only from the point of electricity, it would only be 30 to 40% without any use of heat. But that is not our business for the future. In Germany, we are facing more way to integrate more cogeneration projects, and in this same way, we want to integrate the useful heat, for example, as well. And in the next future, we've seen that our basic pilot plant, for example, this which we've built up in 2009, is underway and function. And by this biogas plant application in some locations in the northern and southern part in Germany, we tried the function of this basic system, and also we've seen it is underway and it could function, and we can also feed some mobility devices as a consumption area. And the basic advantage of a storage system from power to gas means you can use the gas which you've produced by electricity not only to reuse it for electricity, you can also feed mobility, long distance mobility. You can feed fuel or combustion for the shipment, for the aircraft, for example, as well, for the chemistry. Everything is possible, and you can also feed a classical gas turbine with our system to combine the CO2 in a cycling way, so that you also only use the CO2 as a cycling product, as a raw material to store energy, but you will feed it in a cycling process with an existing technology like a gas turbine, for example. That is possible. And one of our quite interesting customers at the moment is mobile application. Audi invented in a first industrial biogas plant with our facility, which we are now integrating to this plant size under the way now in the northern part of Germany, and we are building up this device at the moment until 2013. And Audi can integrate now with the produced power of gas, can produce and deliver to these serial applications in 2013 a classical serial CNG vehicle. That means compressed natural gas vehicle. They could combine it with natural gas fed by renewable electricity, renewable methane. It is our basic principle. That's our projects underway, which we are now focusing on. Not only the Audi project, we have also some other smaller projects under construction. And the next way of integration, the technology will be in 2015. We will provide the market with some project plant size from 1 to 20 megawatts. Every project could be matched and planned from the size of affordable needs. And this means for us could be the market for the power to integrate the renewable energy for a system that will face all challenges in the actual and in the future needs. Thank you very much.
Solarfuel is a very good example for a small startup company that looks very big already. But you actually took the opportunity of working with 2 research institutes and using their technology, and you are basically integrating. It's Fraunhofer and the ZSW in Baden-Württemberg and Stuttgart. And go a little bit back to the beginning. How did you come up with the idea of creating this startup company?
This was in 2007 when our former Mr. Waldstein had the idea, how can I integrate and match this high flux of energy? And then he invested also in technology investigations. How can we reduce CO2 as a molecule, as a chemical storage medium with other molecules, for example? And then he got the contact to the Center of Solar Energy and Hydrogen Technology. And they've done this technology in the early 90s as well to produce with PV-powered electrolysis and to match it with a chemical storage medium. Former times they've produced methanol, but we are convinced due to this existing natural gas grid, which will transport a huge amount of energy in our energy economy, we will produce renewable methane by these solar energy income fluxes, and then that was the basic idea to cooperate with the Center of Solar Energy in Stuttgart, as well as with the Fraunhofer Institute of Wind Energy in Kassel. And our basic principle is to network and to combine suitable technologies, of course, to develop it in a more better way from our actually existing challenges, and the matching and the system aspect. That is our business and network to get in a very rapidly way under the progress of integration basic plans, which we can deliver as the linking instrument between electricity system and a natural gas system. We are producing the linking devices for integrate a huge amount of energy in our natural gas system, which you can deliver for every energy consumer market, which you can imagine at the moment.
What I find fascinating is that Solarfuel, you are just a couple of guys, all of a sudden gets a call from Audi.
Yeah.
And explain this a little bit more in detail. Why did they call you, and why are they now your pilot customer? And it's not a small deal, it's quite a big deal. But I find it fascinating that such a huge company in the mobility sector, one of the biggest automakers in the world, is trusting you, that you can really be part of a new balanced mobility strategy that they have.
Perhaps you keep in mind what are the challenges for the mobility sector in the 2018 in Europe, for example. They have to reduce their CO2 emissions as well, quite radically, and therefore with only electricity vehicles, it could be perhaps a little bit critical to fulfill these threats, perhaps. And therefore, they've said to us, we are a company which are acting in the manufacturing of serial applications or vehicles with internal combustion engine, and let us combine it with a renewable methane. It's also the classical combustion for these units, and if it will be fed by natural renewable energy, then we have the link between a renewable energy source and a fuel for the vehicles. And perhaps they have also trusted in us to build up this plant of 6 megawatt now in the northwestern part of Germany, because we are linked with these institutes, for example. And we have the idea we not only can do everything that's unrealistic, but together with some institutes, for example, and some other cooperation partners, we can match this transfer very rapidly, and therefore now we are building up this 6 megawatt plant, and you are also invited for the next year in 2013 to see the first worldwide feedered plant to build up a storage technology which will derive the mobility sector for the possible idea.
And the final question, solar fuel, are you actually looking for capital?
Of course, that's perhaps I'm also here on this in the moment. Every time we are focusing not only on the engineering, procurement, and construction of these devices, we also want to investigate, for example, a little bit on this focus electrolyzer units. It's one of the basic principal technologies which we are convinced about their importance in the next future. And also, according to our relationship with the Center of Solar Energy and Hydrogen, we are at the time actually were engaging more in this field of electrolyzer units, and our cooperations are underway with other partners from the OEM sector to build up these electrolyzer units, for example, and therefore we are searching for investment capital, and this is our basic idea, focusing not only on the whole system, also on the basic technology electrolyzer unit in the next future steps. And this is the possibility for us to go more quicker in our possible goals for the next future.
Great. Stephan, thank you so much.